Piecewise functions. A piecewise function is defined by pieces of its entire domain. The pieces are not allowed to overlap, otherwise it would not be a function. But the pieces are allowed to be defined as any function we like. To visualize what I mean by defining a function based on pieces of others, let's look at a graph of one. This graph looks like a constant function with 3 as the output for every input smaller than or equal to -2. It looks like the identity function for all of the inputs strictly greater than -2. Writing this as an equation requires a row for each piece and an inequality to represent the piece of the domain it represents. For this one, I'd say that f of x is 3 where x is less than or equal to -2, and x where x is greater than -2. If I'm given a piecewise function, for instance, if f of y is 3y minus 1 for all y less than -1, 2y squared for all y between -1 included and 1, and 5 minus 2y for all y greater than or equal to 1, then I might have a harder time than normal finding my function values. If I'm supposed to find f of 2, then I need to first find what piece of the domain 2 is allowed into, which is the last row. Now I only plug 2 into the last row and get 1. If I want to find f of -3, I can only use the first piece to find that f of -3 is -10. And if I want to find f of 1/2, I can only use the middle piece to find that the output is also 1/2. You can now recognize piecewise functions, graph them, and find their values at specified inputs.